Problem: longest substring with distinct character. So the question is, string S is given. You have to find the length of the longest substring with all distinct characters, which means the longest substring should not contain any duplicate characters. So there are two approaches for solving this problem. Obviously, brute force can be used, but it is not the optimal solution. So first approach is two-pointer approach, and the second approach is binary search approach. And the best is two-pointer approach is the best approach. First approach is two-pointer approach. So in this we'll take two variables, left and right. So initially both variables will be set to 0 and will be pointing towards first variable, that is t. And then we'll keep on iterate right variable. As the right variable keeps on increasing, the map function like keeps on adding new value. Map it contains g and position, which means g and 1. I mean g and 0. Initially g and 0, then after that right variable will go to second, will be incremented. So then e is like added. E is appended to map e and 1. Then after that right variable goes here. Right variable points towards e. So you can see that e is repeated. E is repeated, that's why now the max value will be changed to 2. Max is changed to 2 and the value of e stored in map will be changed to 2, which means second position. And since e is repeated, left will be also changed, and left is changed to e. And after that right is incremented and it points towards k. So when it points towards k is added to the map, and then right is again incremented and s is stored in map. Then after that f s5, then o s6, r s7, and then you can see g. And g is when it comes to like this variable as g, you can see that g is already stored in the map. So in this case you should see that g is in this position as well as in first position. So in this case this g position is changed, because if you see from left to right position, the g is not repeated, but it is repeated in the string. So only this value is changed. So g is changed to 8 in this case. Now after g it comes e. Right is incremented and it points towards e. And in e you can see that again there is e already present in map, which is pointing towards 2. And you can see that 2 is from this position and which is equal to left pointer. So in this case e is updated, max is updated, left is updated as well. So what happens is now the max variable changes to like length of this EASFORG, so which is equal to 7. and 7 is greater than 2, so max variable is changed to 7. And new position of E is, again, it will, this E is changed to 9. And now the new variable, new pointer for left is E. So this is left pointer. In right pointer was also here. Then again, right pointer is incremented. Again, it points towards E. And again, you can see E is again repeated. So E value is changed. Position of E is changed again. E is changed to 10. And also, since it is repeated from here, again left value is changed. And then right variable points towards K. And K, in this case, it is changed to 11. K value is changed to 11, but left left pointer won't be changed. Then and then the value for right is changed, I mean incremented, and it points towards S. And S will be changed to last, its last position, which is 12. And since this is the end of the string, the length is taken, which is equal to 3. But, but the thing is, 3 is less than 7. So the value of max won't be changed in this case. So this is the example. Let's go to second example. So initially left and right variables are taken and both are initially pointed towards first value, and then you can see, and then right value will be iterated to the string. So initially A, I mean map stores first character A as 0, then right is incremented, then it stores B 1, then right value is incremented and it points towards C, and then C value is stored in map C2, and then right is again incremented, D3 is stored, then right value is incremented and E4 is stored, then the right pointer points towards F, so F5 is stored, and then when it comes to this position, you can see that A is repeated. A is repeated, so the value of A is changed to new position of A, that is A6. And since A is repeated in this substring, the left variable also will be changed. Now left will start to point from this position and right value as well. And then the max value will be stored as 6. Since like A, B, C, D, E, F is the substring, the length of that substring is 6. And after that, A is incremented again and it points towards B. It points here. So B value is changed to 7. And it right pointer points towards C, and then value of C is changed in map function. That is C is changed to A. And then again right value is incremented to B, and when it is pointed towards B, you can see B is already repeated. So value of B is changed. Also left pointer is changed in this case. Now left will start pointing towards B. And then you can see the length of string is like ABC, which is equal to 3. Length is 3, but it is less than the max value, which is 6. So the value of max won't be changed here. And then right values like finally would be pointing towards B. And here in this case, B value will be changed to 10. B is changed to 10. And again left pointer will be changed, but and the new value of length will be 1. But the length is again lesser than the max value 6. So max value won't be affected. So here you will get the answer as 6. The second approach is binary search plus sliding window. So in binary search, we'll take two variable low and high. Low is points towards the first first variable and h is equal to like last element of the of the string, which means value of L is initially value of L is 1 and value of h is 13. And with this we can carry middle element, which is like lower plus higher divided by 2, which is 6. So the mid value is 6. And the, I mean, not 6, 7, value will be 7. With the value of mid, we'll like find whether for that, whether the value of mid is equivalent to the length of the substring. So sliding window, so we'll check for 7 correct. So in this you can see 2 is are repeating. So this 7, this string is false. So then we'll check for this. Then you can see again E is repeating. Then from E to G, you can see that no characters are repeating. So hence the mid value is true. So in the next step, the value of low will be changed. Value of low will be changed to mid, which is 7, and high remains the same. So now the value of mid is changed. Value of mid is changed to 10. And so for the length of the substring, then we'll check whether it is possible or not. So 10 means, so initially this will be the substring, and you can see that E is repeating, G is repeating, and many characters are repeating. So we'll like go to next iteration. Again, characters are repeating, and again you can see that characters are repeating, and again you can see the character is repeating. Characters are repeating in this string, in the substring. So the 10 might be false. The value of 10 might be false. So the value of h is changed. H is changed to mid minus 1, which is 9. And low is not changed. And with this help, and after calculating, new value of mid will be 8. Then for length of the substring being 8, we'll be like checking whether it is possibility or not. Then you can see again E is repeating. Again for this substring, again E is repeating. Then for again this substring, again E is repeating. Then again this substring, uh, 2 E's are repeating here. And for then this, again 2 E's are repeating. Then at the end again. So 8 is not possible. So the value of h is changed again. Value of h is changed to 7 and low is also changed to 7. Since low and high are equal, this binary search operation will be ended and value of low is returned. This value of low is returned. In this approach, lower value is returned. Now let's go to next example. So again, initially value of lower is first 1 and the higher is length of the string, which is 11. So with this help, now the value of mid is 6, and we'll check the like for the length of the substring being 6, we'll check whether the characters are repeating or not. Initially, first this substring is checked, and you can see none of the characters are repeating. So this is true. So L is changed to value of mid, and H remains the same. And now the value of mid will be 6 plus 11, which is 17, which is 8. And now we'll be check, checking the substring with of length 8. Of length 8 means initially it will be this. So you can see A and B are repeating in the substring, and then we'll be checking this substring, and again some characters are repeating, and then another substring, again the characters are repeating, and then another substring of length 8, and you can see again B is repeating. So 8 is not possible. So now the value of H will be changed to 7, and value of low is 6, and mid in this case will be 6 again, and obviously in this first case you have seen that 6 is true. So this is the right answer, and 6 will be returned. So value of length of the substring will be 6 in this case. So that's the binary search approach. Now next, let's see the complexities of the two approaches. So two pointer approach, the time complexity is O of n, big O of n, and the space complexity is O of 255. How we got 255? In characters we have 255 characters. Because of that, the space complexity is 255. If you only consider lowercase alphabets, then the space complexity is 26. And if you include lowercase as well as uppercase, then it will be 52. Then same for binary search, time complexity is n log n, which is slightly more than two pointer approach, and because of that, two pointer is the best approach. Yes, so here you can see the code for two pointer approach as well as binary search approach. Quickly take screenshot of this. Thank you. Hope you have learned something new.